video we will learn about the chemical bondings, right? So it is a well established fact that any matter or any substance is composed of atom, but also these atoms, except those of noble gases, do not exist as a independent entity, right? That's why under normal conditions they exist in the form of compounds or some other salts, right? So the smallest entity that can exist independently in the molecule, right? So the atoms exist in state of molecules. For example, the oxygen molecule, in which two atoms of oxygen combine to form O2 molecule, right? And the molecules are formed by the combination of atoms. But first, why do atoms join together? And second, what is the nature of the force that holds together the combining atom in a molecule? So these are two main questions that arises when we talk about molecules. So first, reason for chemical activity of an atom. So basically the chemical activity of an element mainly depends upon the number of valence electrons in its outermost cell. So first we see the example of noble gases like helium, neon, argon, krypton and xenon, radon that have 8 electrons in the last or outermost cell. That means their octet is complete. They exist in the individual atom configuration, right? Because they do not want any other electrons to get stable. But in case of helium, it has only 2 electrons in the outermost shell because it completes its duplet to become stable, as helium comes on the second position in the periodic table. Now talking about elements having less than 4 electrons in the outermost shell are metals and are very reactive, and they tends to lose these electrons. And moving ahead, talking about elements having 4, 5, 6, 7 electrons in the outermost shell are the non-metals because they tends to gain electron to complete their octet, right? And these elements are chemically active also. Elements with 7 valence electrons like fluorine, chlorine are very highly reactive. Now we can see here the electronic configuration of noble gases in this table. Now here the all noble gases are highly unreactive and rather chemically inert, hence they are also called the inert gases. As you can see, the outermost shell of all the noble gases has fulfilled 8 electrons, right? Now moving ahead towards the octet rule. So what is the octet rule? As already stated, noble gases are rather chemically inert. That means they do not react normally under normal conditions. It means that these elements have very stable electronic configuration. Now, we all know that every system in nature tries to attain a maximum stability. Therefore, reactive atoms undergo chemical reaction with other atoms, whether it is a metal or non-metal, in order to acquire the stable octet configuration in their valence cell. And this is known as the octet rule. So basically, octet rule states the stability of an molecule by combining with other atoms. Here, however, hydrogen and lithium tries to have 2 electrons to complete their valence shell. That means completing their duplet also. Here, actually, chemical reactivity of element is because of the tendency of their atom to acquire the nearest noble gas configuration. Moving ahead in this, we have the Cossels-Lewis theory of chemical bond. So, according to this theory, early speculations about the nature of chemical bond supposed that certain types of chemical species were joined by a type of chemical affinity between them. Here, Berzelius in 1819 developed a theory of chemical combination stressing the electropositive and electronegative nature of the elements. Here, in 19th century, Franklin developed the theory of valency, originally called the combining power, here in which atoms were joined due to attraction to each other. After that, in 1916, Lewis and Cossel put forward the theory that in order to acquire stability, atom with less than 8 valence electrons bonds together to complete their respective octet. It may be a metal or maybe a non-metal. It only states that the elements having less than 8 valence electrons will undergo combining or in bonding, right? Therefore, the causes of chemical combination is the tendency of the combining atom to acquire the nearest noble gas configuration by redistribution of electron amongst themselves and become stable. Here, the chemical bonding is the process responsible for the combination of combining atom by attractive interaction resulting in the lowering of the energy of the system. So, if we take some examples, for example, sodium and chlorine. So chlorine tends to gain one electron and acquire minus one charge, and sodium tends to lose one electron and will gain one positive charge. And this gaining and losing of electron will tends to make a bond between sodium and chlorine that will result in the formation of a NaCl, that is sodium chloride molecule, by the redistribution of electrons between these two atoms. So this is about this theory. Now moving ahead, the nearest noble gas configuration can be achieved by two methods: by complete transfer of electron or by sharing of electron. Now talking about these two methods, so first is the electrovalent or the ionic bond, in which the complete transfer of electron takes place to make a stable configuration in a compound or a molecule. Now here, when combining atom acquires the nearest noble gas configuration by complete transfer of one or more electrons from one atom to another, the bond thus formed is called the electrovalent or the ionic bond. So on the combining atom loses its valence electron and changes into a positive ion, that is known as the cation, while the other atom that gains the electron will convert it into a negative ion, that is known as a anion. Thus each combining atom acquires the stable configuration of the nearest noble gas, and the forces of attraction between these two atoms will be the electrostatic forces of attraction in a 3D definite geometry pattern to form ionic crystal. Thus ionic and electrovalent bonds may be defined as the electrostatic force which holds the oppositively charged ions. Now for example, we can see the formation of sodium chloride. So here sodium has one valence electron, right, and chlorine has seven valence electrons. So in this, these atoms will have tendency to gain and lose electrons. In sodium, sodium can easily lose one electron to gain the stable noble gas configuration, right, and chlorine will tends to gain one electron, right, to become stable and complete its octet. So in this, sodium loses its one electron, chlorine gains this electron, and hence a electrostatic bond is formed between these two atoms, right, between the cation of sodium and anion of chlorine, and this electrostatic force of attraction will result in the formation of NaCl, that is the sodium chloride, right. Now moving ahead towards calcium oxide. Similarly, calcium oxide has electronic configuration like calcium has 2, 8, 8 and 2. That means it has 2 valence shell electrons while oxygen has 6 valence shell electrons. So in this we can see calcium tends to lose these 2 electrons while oxygen tends to gain 2 electrons to become stable and complete its octet, right. So in this, a calcium will lose its 2 electron and give it to oxygen, that will result in the formation of CaO, that is calcium oxide, by the complete transfer of 2 electrons from calcium to oxygen, and the forces of attraction between these two atoms will be also the electrostatic forces of attraction. So this is how the calcium oxide is formed. So I hope this topic is now clear to you. Thank you.